Hello and welcome. This is Safa. In this episode, we will learn how to make an AUV follow a predefined path using a sliding mode control. The idea is simple. We have a reference path, for example, a straight line. The AUV moves in the water and may deviate due to disturbances. Our task is to minimize the cross-track error, which is the distance from the path. For simplicity, let's consider motion in 2D. X and Y are the positions. Phi is the heading angle, U is forward speed, and R is the yaw rate, which is our control input. The sliding surface is defined in terms of the cross-track error, EY, if this sliding variable goes to 0. It means the AUV is exactly on the path. The SMC control law has two parts: the equivalent control to stay on the surface and a switching term to force the trajectory onto the surface quickly. The parameter K must be chosen large enough to overcome disturbances. To test the controller, we'll use a simple path. The x-axis will start the AUV 5 meters above the line, so we can see how the controller drives it back to the path. Okay, let's go to MATLAB. Okay, parameters, initial state, y is 5 and start for plotting, simulation loop, and sliding surface, equivalent control, SMC control law with boundary layer. Okay, output dynamic and plot result. Okay, run this code. Blue is AUV path and red desired path. As we can see, the AUV smoothly converged to the reference path. The SMC law successfully compensated for the initial deviation. In the next episode, we'll move to adaptive sliding mode control, which handle uncertainties in the vehicle dynamic. Thanks for watching. This is Safa.